My name is Maria Ritola. I'm the co-founder of Iris. As said already, Iris is a 2-year-old startup that we started at Singularity University, a global solution program. What we are doing is that we are teaching an AI to understand and read scientific language. Our goal is to speed up the process of scientific discovery, and within 6 to 8 years from now, our goal is to build an AI scientist. So today we're going to talk about AI and decision making, and my focus on that topic will be on AI, the potential of AI to remove biases from our thinking, as well as to improve our ability to use data that is accessible to us. But before we go to that in depth, let's take a couple of steps back. So before I started Iris, I worked as a researcher. And I did used to struggle with a vast amount of scientific knowledge that is accessible to us. More than 3,000 research papers are published each and every single day. That is a huge amount of knowledge, like truly big data, but it has become a headache for us humans because there is no way we can read and understand more than a small fraction of that data. Let's take a quick thought experiment. Imagine that you read 1 book per week throughout your life. How many books will you be reading in total? The right answer is around a couple of thousand. This is 0.1% of the selection of great libraries. What I'm trying to say here is that we humans, we're pretty bad at crunching data. Luckily, data is not the only thing that is growing at an exponential rate. Computing power is too. And these two things enable us to build neural networks that basically help us find patterns from huge amounts of data. And this is the approach that we've used at Iris to teach the algorithm to actually understand scientific language from research papers. Our motivation to do this? Well, at Singularity, we were thinking, actually our goal and our only homework at Singularity a couple of years back was to positively impact the lives of 1 billion people. So that was the homework. And so we were thinking with my friends that we would have already solved quite many problems in this world if we had been able to optimally leverage what the scientific community has come up with in the past couple of decades, right? And so we used the method called deep learning to build an algorithm to basically what we do is that we built document fingerprints of all the scientific documents, and then we match those fingerprints. Now, what makes this approach very useful is that we are able to build contextual understanding to the algorithm. This is very different compared to the keyword-based tools. Now, if you start a research project with a keyword-based tool, as a researcher, you know that you need to know the search terms. Now, when you start a research project, by definition, you do not know the search terms. You need to figure them out. And that might take weeks, if not months, to figure out. Now, with Iris, you don't need to know the search terms anymore, because Iris will be able to find them for you. Iris will be able to understand that the word charge means one thing in one context and another thing in another context. It will also be able to build bridges across disciplines, so you can map out scientific knowledge across disciplines, even on those disciplines that you're not familiar with and you're not an expert on. So that's a tool that we are building. We tested the technology this winter with Chalmers University. We wanted to see which parts of a systematic research mapping study we can automate or semi-automate with Iris. We started with a research mapping study that had already been done on autonomous vehicles. Chalmers University started with 11,000 research papers, and it took 3 months for them to do that mapping study. Now, our tentative results show that on 90% confidence level, you can do that same work with Iris in 2 days. If you want to reach out to 100% confidence level, it's going to be more, but still a lot less than 95 days. So, and this is just the beginning. Like right now we're matching research papers. What we want to do next is to extract hypotheses from research papers, relate research hypotheses next to each other and basically see their relation, and then come up with new hypotheses, creating new knowledge based on our existing knowledge base. So that's a short description of what we do. Over to Kate at this point, and then we're going to discuss about the decision making more in depth. Thank you.